Okay, today in this video we're going to learn how to address equations that are linear of arbitrary order, but they have inhomogeneities. So far we have only solved homogeneous differential equations with constant coefficients. Here we're going to learn how to deal one method as to how to deal with inhomogeneities for this kind of equations. In particular, the method that we're going to learn is called the method of undetermined coefficients. I lost my hair in order to be able to gather all this knowledge, so I hope that I can transmit it to you. Alright, so the method was going to consist of 5 steps. So first, what we will do when presented with an equation with an inhomogeneity is, okay, fine, let's solve first the homogeneous problem. And we know how. Characteristic polynomial, roots, and the recipes that we learned in the previous video. Then, with that, we have xh of t. xh of t is the solution of the homogeneous problem. Okay, remember theorem 3. Of the theorems that we saw, there was one theorem, theorem 3, if you remember, that said that the solution to the full problem is equal to the solution of the homogeneous problem, the general solution to the homogeneous problem, plus a particular solution to the non-homogeneous problem. So our objective after finding xh of t, which is the solution to the homogeneous problem, is to find one, and just one, particular solution of the non-homogeneous problem. How are we gonna do that? Well, by making a guess. That's right. We're gonna learn some algorithms to make really well-educated guesses as to what a particular solution could be. We just need to find one. The moment we find one, we add it up to the homogeneous solution and we get the general solution of the non-homogeneous problem. Okay? So we make a guess and we're gonna learn how to make those guesses. After making the guess, there's one thing we need to check. Is my guess a solution of the homogeneous problem? Because if it is, it's not a good guess, as we will discuss. Okay, so what happens if my guess happens to be a solution of the homogeneous problem? Well, you're slightly screwed if that's the case. So you need to upgrade your guess in order not to be exactly like a solution to the homogeneous problem. We will see. How do I upgrade it? Well, multiplying by powers of t. We will learn how exactly. Alright, once we've got that, we have a guess. We plug in the guess into the equation. So this is, as I said in previous lectures, right? We're going to be asking math. Oh, here's my guess. Is that a particular solution? Math, what do you think? And math will tell you, yeah, it is a particular solution and with these coefficients. Or math will tell you, no, it's not a particular solution. I'm sorry, you need to try again. So math will tell us if we're all right. Once we found the exact form for xp of t, after plugging into the equation, we will write the general solution as the sum of the homogeneous solution plus the particular solution we found. Let's learn what are good guesses first. So I'm going to give you some first algorithms for guesses, and we're going to see with examples how to apply them. All right, let me erase the board. All right, so here's a guide for guesses based on the form of our RT, an initial guide. We will start building intuition out of it. So let's see, if R of t is a polynomial, then your guess should be a polynomial. A particular solution, if there's a polynomial here, well, very likely it would have to be a polynomial. So an educated guess would be have a polynomial in it. All right, if the inhomogeneity is an exponential, then a good guess would be an exponential of the same exponent, because exponentials and their derivatives become exponentials as well, so there must be a particular solution that has to have exponential form. If the inhomogeneity is trigonometric of any kind, you need to prescribe a sum of a cosine and a sine. Oops. This should be a sine. A sum of a cosine and a sine of the same argument. This is true if it's a sum, if it's a sine, if it's a cosine independently. Why? Because derivatives interchange the sine and the cosine. You have to put them together. Of course, we will learn that, there are tricks. You don't always have to try the full guess. Sometimes you get away with trying only one of them, but I would recommend against it. I will do it maybe in one example or two, perhaps, but I would recommend against it because that is based on intuition, and this gives you an algorithm. Relying on an algorithm is much more solid than using intuition. True that if you use intuition, you're gonna work less, but it's more likely that you get it wrong. So I would recommend always to do the full guess. And you see sometimes one of the coefficients will be 0, math will tell you when there's 0. Sometimes your intuition will tell you already when there's 0. But I will recommend you do the full guess. Now you have a product of two functions, you're going to have to make a guess that is the product of the functions, right? In particular, exponential trigonometric is easy. Again, same thing as before. This should be a sign. So you do the exponential times the trigonometric. Yeah, so maybe you want to have another constant here. It's not needed because a constant here can be reabsorbing the constants here. Our mission would be to determine those constants. So those constants, A, B, alphas, those are the undetermined coefficients that you have to determine. All right, this is a guide for guesses for particular solutions. Let's see them in action in examples, and I think we will understand much better how to use it once we see examples. Let's erase the board. All right, let's solve this one. Find the general solution of this equation. As you can tell, it's linear, second order ODE, constant coefficients, but you get an inhomogeneity. The inhomogeneity is a polynomial, so our guess is going to be a polynomial. But first, let's follow the steps. First, let's find the solution to the homogeneous problem. So, find XH solution to x dot dot minus 4x equals 0, the homogeneous version of the problem. All right, how do we find XH? Well, first, characteristic polynomial, remember? So, characteristic polynomial, it's lambda squared minus 4. Remember, not 4 lambda, 4. Okay, the typical mistake. All right, so the roots of this one, it's very easy. The roots of this one, you can tell already what they're going to be, because if we equate lambda squared minus 4 to 0, we get that lambda is equal to plus minus 2. So we have two real roots. Let me just write it here. Lambda 1 is 2, lambda 2 is minus 2. All right, so two simple real roots. Okay, since it's two simple real roots, we know XH of t is going to be equal to its exponential functions. So it's some constant c1 e to the 2t plus c2 e to the minus 2t. Okay, so we found the homogeneous, so the solution to the homogeneous problem. Wonderful. Now we need to find an xp. So how do we find an xp? So this is half of my solution. All right, how do I find xp? Let me erase this. Let's find xp. So I store the solution to this problem here because I'm gonna need it. And now what we do is let's make a guess for xp of t. Now when you make a guess, you don't know if the guess is good or not. Math will tell you if it's good or not. Now the guess here is like, well, let's find a polynomial. That's very likely that a polynomial will be a solution, a particular solution of this. And then it's a polynomial of the same degree. So the guess we make is alpha 0 plus alpha 1 t plus alpha 2 t squared. If we do that, we get that this is the same degree polynomial as this one here. All right, so now what we do is we plug in the guess into the equation. To do that, the first thing we do is, well, let's compute the derivatives. So if xp is that, then xp, let's write it like that, xp dot is 2 alpha 2t plus alpha 1, and xp dot dot is derivative again, is just 2 alpha 2. All right, we plug it into one, plug into one, plug this, and that. We open a wormhole. A wormhole is a connection between 2 points in space-time. If it's traversable, you can go through, you can use it as a time machine or to travel, but that's a story for a different episode, not for this one. Here, I open the wormhole in the whiteboard manifold, and then what I do is I plug in x dot dot p and xp into one. But that's easy, right? Because the first one is x dot dot. X dot dot is just 2 alpha 2. Then minus 4 times. And then I write alpha 0 plus alpha 1 t plus alpha 2 t squared. And that's equal to 8t squared minus 2t, right? So this thing is xp dot dot, and this thing is xp, which is what we have plugged it in. Now notice, this equation has to be true. If this is a real solution, this has to be true for all values of t real. So what does that mean? Well, if it has to be true for all values of t, maybe for one value of t is a coincidence and it's true, but if it has to be true for all values of t, the only way that's happening is if everything that multiplies t squared, all the coefficients of t squared on the left are equal to all the coefficients of t squared on the right, all the coefficients of t on the left are equal to all the coefficients of t on the right, and all the independent terms of the left are equal to all the independent terms on the right. Otherwise, it cannot be true for all t simultaneously. All right, let's do that. Let's write the equation, the equations that we get when we equate the coefficients of the different powers of t. Let's begin with t squared. Coefficients of t squared. What do I have on the left? Minus 4 times alpha 2 multiplies t squared on the left, nothing else. So this is minus 4 alpha 2. On the right, what multiplies t squared? Number 8. Wonderful. Now, coefficients of t. On the left, I only get minus 4 times alpha 1. Minus 4 times alpha 1. That's the only thing that multiplies t on the left. On the right, minus 2. Wonderful. And now the coefficients of this t to the 1 or t to the 0, the independent terms, okay? So the coefficients of t to the 0, on the left, we get 2 alpha 2 minus 4 alpha 0, minus 4 alpha 0. And on the right, there's no independent terms, so it's a 0. All right, wonderful. So look at that. We have 3 equations, linear equations for 3 unknowns. We can solve it. In fact, if we solve it quickly, we get that alpha 2 is equal to minus 2, alpha 1 equals 1/2, and alpha 0 is minus 1. Wonderful. So this is math telling you, yeah, you plugged it in and I tell you, a solution like that only works with the values of the coefficients, alpha 2 equals minus 2, alpha 1 equals 1/2, alpha 0 equals minus 1. Maybe there are other solutions, but not of this form. Of this form, only that one. Wonderful. So we found a particular solution. Now substituting these values on this equation, on equation 2, so we input those values into 2 and we get that xp of t is, I'll start with alpha 2. Alpha 2 is minus 2, so minus 2 t squared plus 1/2 t minus 1. That's my particular solution. Wonderful. We have not finished. This is the second part of the solution, but the real solution is through theorem 3 tells us that the solution to the full problem is the solution of the homogeneous problem plus the general solution to the homogeneous problem plus a particular solution to the inhomogeneous one that we just found. So that means that the total solution, the final answer that gets the full marks, that is, that we have there, C1 e to the 2t plus C2 e to the minus 2t plus, or minus, 2t squared plus 1/2 t minus 1. And this is the solution to the problem at hand. Hopefully not too difficult. This is an example where the inhomogeneity was a polynomial. Let's do more examples. Erasing board. All right, if you see, we have to find the general solution of this equation. Now, the homogeneous part is exactly the same as before. So step 1, find the solution to the homogeneous problem. We've already done it in the previous exercise. So we have the homogeneous solution. This is step 1. Solution of x dot dot minus 4x equals 0. We have it already, it's that one. We did it in the previous example. Now, we have to make a guess for the particular solution. Now, let's just store this and then let's guess according to our algorithm. Look, if this is an exponential here, derivative of exponentials are exponentials, the function is an exponential, it makes sense that the guess should have exponential form. So let's guess xp of t is some constant times the exponential of 3t, the same as the inhomogeneity. Notice that step 3 that we haven't done before, because it was a polynomial and the solutions were exponentials, here apply. Step 3 tells me, make sure that your guess is not a solution to the homogeneous problem. And we check the homogeneous problem, we have two solutions, right? E to the 2t, e to the minus 2t. Luckily, this is a 3. If this were a 2, our guess would not be valid. And that we will see later on, but that's keeping in mind. First check, all right, my guess will not look like any of the solutions of the homogeneous problem. If it were, we have to upgrade my guess, but there's no need, okay? There's no need because it's not coincide. We will see how we upgrade it later, if that's the case, if we need it. But not in this case, because this is a 3, this is a 2, the solutions are independent. XP is independent from the solutions to the homogeneous problem. We will see what the problems are when they're the same and why we have to upgrade. Anyway, so we guess that. Let's compute the derivatives. So xp dot would be 3a e to the 3t, and xp dot dot would be 9a e to the 3t. All right, so let's plug this plug into 1, and then the wormhole that takes me to the far side of the uniboard. So we get here the out region of my wormhole, and then I'm gonna plug in this, and that into 1, and what I get is the following right here. So we get 9 alpha, oh, I call it alpha, 9a e to the 3t minus 4a e to the 3t equals the inhomogeneity 2e to the 3t. Okay, I just plugged in x dot dot, and then minus 4, this is x, right? So let me just write it here. This thing is xp dot dot, and this thing here is xp, right? All right, nice equation. Look, I can simplify the exponentials out, and what I get is that 9a, oh, the 9a minus 4a equals 2. Oh, how simple. So this means that 5a equals 2, which means that a is equal to 2 over 5. Oh, there we go. We found a particular solution. xp of t is equal to 2 over 5 e to the 3t. Now that's the second part of my solution. I haven't finished, I don't get full marks yet, I have to put them together. The solution to the full problem, x of t, which is of course the sum of the homogeneous solution plus the particular solution, right? Now, this thing, if I substitute, I get c1e to the 2t plus c2e to the minus 2t plus 2 over 5 e to the 3t, and that is the solution to the full problem. Not too difficult, I hope. All right, let's see another example. How about if this gets substituted by a trigonometric function? Let's see what happens. All right, let's do now an example with a trigonometric inhomogeneity. So for this one, you may be tempted to guess that the particular solution has only sign components, right? Because the inhomogeneity is a sign, the function could be a sign. If I take the second derivative of a sign, I get another sign. So maybe we don't need the cosine component, you may guess. And maybe you're right, but if so, math will tell us. I don't know, I mean, that kind of intuition may work this time, but may not work in others. Let's see if it works this time. For now, we're gonna be conservative, and we're gonna make the guess that this could have a sine component and a cosine component. All right, that means that the first derivative of the particular solution is going to be twice a cosine 2t plus minus twice b sine 2t, and the second derivative will be 4 times a minus 4 times a sine 2t minus 4 times b cosine 2t. All right, let's plug into 1. If we plug it in, we open the wormhole and takes us all the way to this side of the uniboard, and then we plug it in and get minus 4a sine 2t minus 4b cosine 2t minus 4 times a sine 2t plus b cosine 2t equals 1/2 sine 2t. So this thing is xp dot dot, this thing is xp dot. All right, so we now simplify and we get that it's equal minus 8 times a sine 2t minus 8 times b cosine 2t equals 1/2 sine of 2t. Now, this has to be true for all t. The only way that happens is if the coefficients of the sine on the left are equal to the coefficients of the sine on the right. And also if the coefficients of the cosine on the left are equal to the coefficients of the cosine on the right. Let's do that. That gives us two equations. Coefficients of sine 2t. On the left, we get minus 8 times a. On the right, I get 1/2. The coefficients of the cosine of 2t. On the left, I have minus ab. On the right, there's no cosine, that's a 0. That gives me that a is equal to minus 1/16, and that b is equal to 0. Look at that. The original intuition may have been right. There's only sine component on this case. All right, let's write the particular solution. X of p of t, xp of t is equal to a minus 1/16 sine of 2t. Now we can write the real solution, the solution that will give you full marks, x of t, which, let's remind ourselves, is the homogeneous solution plus the particular solution we just found. So that means that x of t is equal to c1 e to the 2t plus c2 e to the minus 2t minus 1/16 sine of 2t. And this is the solution to our problem. It seems that in this case there was no need for a cosine guess, right? Can we do that every time that we get even derivatives like that? Like a derivative and zero derivative and second derivative, transform sines into sines. Will this be true? If this is a sine on the right, why do I need a cosine at all? I don't know. Let's see. Let's put it to test with a small change on this problem. All right. Let's do another example where the inhomogeneity is being slightly modified. Same equation on the left, different equation on the right. We have that the inhomogeneity is the product of an exponential times a trigonometric. So the recipe would be always consider full trigonometric with sine and cosine times the exponential. And you may be tempted to say, oh, same as before, right? Because there's only even derivatives, then I only have to do the sine guess, not the sine and cosine guess. Well, let's see in this case. Now, I didn't do as before, first derivative, then second. I wrote already the second derivative because it's long. Please do it yourselves. It's just arithmetic of derivatives and the product rule. Derivative of this one and this one without derivation, plus derivative of this one and this one without derivation. All right, and then you do it again, and then you get all these terms that I have here in the second derivative of p. Please do it yourself. All right, so now let's regroup everything that multiplies the cosine and everything that multiplies the sine together. So let's count on the sine. We have 9a from the first term multiplying the sine. We have minus 4a minus 12b, and then minus 4a. That multiplies the sine of 2t. All right, let's do the same with the cosine. We have 9b for the cosine from the first term, minus 4b, plus 12a, and then minus 4b. That multiplies the cosine of 2t. And on the right hand side, I get twice the sine of 2t. Again, this has to be true for all t's. which means that the only way that's true is that if all the coefficient of sine to t equals the coefficient of sine to t on both sides, the coefficient of cosine of t to t equals the coefficient of cosine to t on both sides. So let's equate the coefficients on both sides. First, coefficients of sine to t. Okay, simplifying. 9a minus 4a, 5a. Minus 4a, 1a. So this thing is a minus 12b equals on the right hand side to the coefficient of sine to t, which is 2. Now the coefficients of cosine to t. All right, 9b minus 4b is just 1b plus 12a equals, there's no cosine on the right, equals 0. And we can solve this system. The solution to this system is not too difficult. I'll write it. A, it's equal to 2 divided by 145, and b, it's equal to minus 24 divided by 145. All right, so we get the particular solution. Look at that. In this case, there's going to be cosine factor. So yeah, you cannot actually say that you're going to have only sine. Okay, so that's why I always recommend that you make the full guess always, right? Anyway, let's write it. The particular solution of this case, it's equal to e to the 3t from this one, and then 2 over 145 sine of 2t minus 24 divided by 145 cosine of 2t, and that means that I can write the full solution. X is equal, x of t, it's equal to the homogeneous one, c1 e to the 2t plus c2 e to the 2t plus the particular one e to the 3t multiplying 2 over 145 sine 2t minus 24 divided by 145 cosine 2t, and that is the solution to the problem in this case. All right, let's do one more case. All right, a little bit of time travel in action for the next example. Let's solve this non-homogeneous equation. Now, find the general solution of x dot dot plus x dot minus 4x equals t squared exponential of 3t. Now we see right away that this is an ordinary differential equation. It's second order and it's linear and it's non-homogeneous. So we know that the solution, the general solution of this equation is going to be a linear combination of the general solution of the homogeneous problem plus a particular solution of the non-homogeneous problem from the theorems that we proved in past lectures. So wonderful. So first of all, let's find the solution to the homogeneous problem. So maybe step 1 if you want. Find xh of t, solving xh dot dot plus x dot h minus 4xh. I just wrote the h here to notate that this is the homogeneous version, so you see the same equation but the homogeneous version. How do we solve that? Well, find the characteristic polynomial. So the characteristic polynomial, it's trivially lambda squared from this one plus lambda from this one minus 4. All right, now we need to find the roots of the characteristic polynomial. So the roots, we can use the quadratic formula, and we get that those roots are minus 1 plus minus the square root of 1 plus 16 divided by 2. All right, so we get two real roots, right? We get lambda 1, first eigenvalue, it's minus 1 over 2 plus root of 17 divided by 2. And the second one, lambda 2, is minus 1 over 2 minus root of 17 divided by 2. So, two real roots, two simple real roots, then we know the solution to the homogeneous problem is going to be a combination of two exponentials, one per eigenvalue, e to the lambda 1t and e to the lambda 2t. So in this case, constant a, exponential of the first eigenvalue t. Now I'm going to take a common factor 1 over 2, and that means that I have root of 17 minus 1 for the first one times t, plus b exponential of same thing here. I'm going to take minus 1 over 2 as common factor, and that gives me root of 17 plus 1 t. And that is the solution to the homogeneous problem. All right, so we have the first solution. We found this component. Now we need the particular solution. To do that, let me move this result that we have here and erase the board. Like that. And we're going to now make an answer. We're going to make a guess as to what could be a good particular solution. Notice that in this case, we have a particular solution that will be similar. We have to be similar in form to this one. And we say that this is a product of a polynomial of order 2 times an exponential. So our answer is going to have to be our particular solution. We're going to make the answer, then use the same conventions in the notes. It's the product of the exponential and then a generic polynomial of the same degree. So we have alpha t squared plus beta t plus gamma. All right, and that is the answer that we are making. Okay, now we need to plug in the answer into equation 1, and to do that we need the derivatives. So let's take the derivatives. The derivatives are, so this, maybe I'll write them here. xp dot is, we take the derivative of the first one, which is 3 exponential of 3t, all right, times the second with a derivation, alpha t squared plus bt plus gamma, and then plus the exponential of 3t and the derivative of the first one, of the second one, which gives me 2 alpha t plus beta, right? Then we can put it all together in here, and we get that as a common factor is exponential of 3t, and then we see that we have 3 alpha t squared, 3 alpha t squared, plus 3 beta t plus 2 alpha t, so 3 beta plus 2 alpha t, right? And finally we get 3, here we have plus 3 gamma plus beta, so plus 1 beta, so 3 gamma plus beta. All right, so that is the first derivative. Now the second derivative, p, we take yet again one more derivative on here. So again, same thing as we did before, 3 exponential t, then the same thing, 3 alpha t squared plus 3 beta plus 2 alpha t plus 3 gamma, 3 gamma plus beta, all right, plus the first one without derivation, so exponential of 3t times the derivative of the inside, that gives me 6 alpha, and then plus 3 beta, 6 alpha t, sorry, plus 3 beta plus 2 alpha. Okay, so we put the two terms together, we get a common factor e to the 3t, and now we go term by term. First, the terms with t squared, so let's see, 9 alpha t squared and nothing coming from the second. Okay, terms with t, so we have 9 beta plus 6 alpha, and then here with t we get another extra 6 alpha. So 9 beta plus 6 alpha plus 6 alpha multiplied t gives me 9 beta plus 12 alpha times t. All right, now the independent factor is 9 gamma plus 3 beta plus 3 beta plus 2 alpha. So 9, I don't need the parentheses, but I write it anyway, so for clarity, so you see where it comes from. 9 gamma, right, from this one, then 3 beta plus 3 beta, 6 beta, plus 2 alpha. All right, and that's the second derivative. Now, we have to now plug it into the equation, it simplifies quite a bit. I'm going to just write the simplified expression. I'm going to actually conjure, I'm going to summon the simplified expression. Simplified expression now. All right, so this is what happens when you plug in this expression, and this expression into this equation, and you group together the terms that go with t squared, with t, and independent. Now, obviously, the exponential of 3t cancels, all right? And now we are left with an equation on, one equation of a polynomial equated to another polynomial. So, we have three unknowns, alpha, beta, gamma, and how many equations? 3, because we know that the three equations, all the coefficients of t squared, of all the powers of n, t squared, powers of t squared, t, and the independent term, have to be equal on both sides of the equation. So we equate them. So we have, equating the coefficients of t squared. Well, on the left, I have a alpha. On the right, I have 1. A alpha equals 1. That makes it very easy. Alpha is 1 over 8. All right, what about the coefficients? The coefficients of t. Well, the coefficients of t on the left is 8 beta plus 14 alpha. And on the right, there are many, 0. Now, finally, the coefficients, it's t to the 1, the coefficients of t to the 0, the independent term. And that is 2 alpha plus 8 gamma plus 7 beta on the left and also 0 on the right. So I have this system of 3 unknowns and 3 equations where alpha I already solved. I can solve for the others. It's easy, but just arithmetics. Let me just write the result. So the result is beta is equal to minus 7 divided by 32. And gamma is equal to 41 divided by 256. All right. Well, that means that I have the solution. So the solution is of this form, the original answer. This is the answer that we made. So we substitute the coefficients and we get that the particular solution it's equal to the exponential of 3t multiplying 1/8 times t squared minus 7 divided by 32 times t plus 41 divided by 256. And that's the particular solution. All right, the exercise is not done. We need the general solution to the full equation. So finally, we write the final solution to the exercise is the combination of the two. So it's, let me just try to write it here, a exponential of 1/2 root of 17 minus 1t plus b the exponential of minus 1/2 root of 17 plus 1t plus the particular solution plus e to the 3t that multiplies 1/8 t squared minus 7 divided by 32 t plus 41 divided by 256. And that is it. This is, for real, the solution to the exercise, the one that will give you full marks. All right? Okay, so this is the last example we'll do in this video. Now, the one thing that we need to learn what to do, so remember, one thing that was nice of this exercise is that the inhomogeneity doesn't look like any of the particular solutions to the equation. To begin with, because the reason because the exponent was different. Now, it would have been different if the exponent would have been this, minus 1/2 root of 17 plus 1t. If that would have been the exponent, then it would have been a non-zero overlap between the answer and the solution, the general solution to the homogeneous problem. And in that case, things are not as simple. We need to upgrade our answer. It's not going to be valid. That we will discuss in our next video. Okay? So, but for now, this is the end of the video, of the first video on solving non-homogeneous linear differential equations using undetermined coefficients. And I'll see you in the next video. All right, going back to my time. Bye bye.